All right, guys, Mr. Mice is back here with you, and this time we're talking about the direct comparison test, and I'll do another video on the limit comparison test, so I'll split these up into two videos here. First, I'd like to talk to you about the direct comparison test. Now, in the previous section, the last video, I talked about why the P-series and harmonic series test, though not too hard, we're going to definitely want to remember the harmonic series, because we actually are going to use the harmonic series a lot of times when we're looking at the direct comparison test, because what the direct comparison test tells us is that if we have a series and we know a series that's bigger than that series and that bigger series converges, then the smaller series must converge. Kind of makes sense? Hopefully, I mean, I ask you, and I don't know if you're saying yes, but hopefully you're saying yes. Also, if that smaller series diverges, then the bigger series has to diverge, right? Because if the smaller diverges, then the bigger diverges. If the bigger converges, then the smaller also converges. That's the direct comparison test. We're going to see if we can find a series that we can relate or compare the series that we're doing with. But if the bigger series diverges, does that mean the smaller series diverges? Not necessarily. We actually don't know anything if the bigger series diverges. So if that happens, we're going to have to, think about another series that we could maybe compare it to. Let's take a look at 3 examples here. So we've got our first example, and what we want to do is we want to think about a series that we already know that might be similar to what we have here. And for this one here, I'd like you to consider, let me see, I'd like to change the color of my pen here. Consider this part right here. I changed the color, I didn't even change the color. Come on, dude. All right, this one right here, 1 over 2 to the n. This is the same as 1/2 to the n, right? And that is a geometric series. So notice here that 1 over 1 plus 2 to the n is always going to be less than 1 over 2 to the n, right? If I add, did you like that ding dong? They were calling me. Anyway, notice here that if we add another number in the denominator, that numbers, this number right here is going to be smaller than that one, right? I mean, the whole thing, right? We get a bigger number in the denominator. That's going to make the whole thing smaller. So we can clearly see that 1 over 1 plus 2 to the n is going to be less than 1 over 2 to the n. So we're gonna say, here's what we're going to do. We're going to compare to the integral of 1 over 2 to the n, because that's what we're looking at comparing to. And we know that this one converges by the geometric series test. So, since this converges by the geometric series test, since we know that this is happening here, that our term that we're looking at is smaller than the previous term, or the one that we're comparing it to, we know that our series also converges by the direct comparison test. All right? So we have to think about a series that we know, and we can easily determine using some other test, and then we can use the direct comparison test to do that. Okay, let's take a look at example 2. So what does this kind of look like? Well, it looks like we're going to use that harmonic series we talked about before, 1 over n. All right, so we're going to say, let's compare to 1 over n. Now 1 over n diverges. So if 1 over n diverges, what we want to see happen is we want this 1 over n to actually be the smaller series, and we want our series that we're looking at to be the larger series, because if the smaller series diverges, then the larger series must also diverge. So let's take a look at that. 1 over n minus 2 is in fact going to be greater than 1 over n, right? Because the minus 2 makes the denominator smaller than the n, and so it's going to be bigger. So the series 1 over n minus 2 diverges by the direct comparison test. All right, let's take a look at one more here. Now, I would probably say let's take a look at comparing it to 1 over root n. 1 over root n is a p-series where p is equal to 1/2. Since that's less than 1, we know that this diverges. Right? The problem with that is that 1 over root n plus 1 is actually smaller than 1 over root n. So that doesn't help us at all, because if we actually want r's, if this in fact diverges, we want r's to be the bigger function or the bigger series, and we want the smaller series to diverge. So this doesn't work. We can't compare it using that. All right. So what we're going to do is we're going to compare to something that is smaller than 1 over root n, and that's 1 over n, right? 1 over root n plus 1 is going to be bigger than 1 over n, right? Because n is the 1 power, root n is the 1/2 power, so this is always going to be all in total a bigger number than 1 over n. Since this diverges by we could call this a harmonic series. We know that ours, 1 over root n plus 1, diverges by the direct comparison test. All right? So there you go, guys. That is the direct comparison test. Just remember, you want to compare to a series that you already know is easy to figure out if it converges or diverges. All right? See you guys later. Bye.